So today we will look at first four problems of div 4 of Codechef Starters 183. So the first question is quite trivial. There is a cricketer who has made X number of runs and he can either score uh, 0, 1, 2, 3, 4 or 6 in a ball, and we need to predict what's the maximum amount of sixes he could have scored. So it's quite well, it would just be X by 6. Now let's look at the second question. So we have n sticks of length 1 comma 2 comma n. So they are n sticks, and the length of first stick is 1, the length of second stick is 2, the length of third stick is 3, and so on. The length of nth stick is n, and we need to pick 3 such sticks and satisfy these constants. That is, we need to satisfy 2 times of max of a comma b comma c is less than equals to a plus b plus c, and the 3 sticks that we have to pick, their parameter should be maximum, and we have to print -1 if it is not possible to pick such pair of 3 sticks. Okay, so uh, let's say a is less than b and b is less than c. So if we consider this, then we can simplify this equation like this. So max of a comma b comma c would be just c. So our equation will become 2c is less than equals to a plus b plus c. That will give us c is less than a plus b. Okay, now since c is the largest stick that we are taking, and the largest possible length of the stick that we can take is n, so why not just take c equals to n? So if we take c equals to n, then what will happen? Then our equation will become that a plus b is greater than n. Yeah. So we need, so that means uh, if we take any two sticks whose sum is greater than n, then that would satisfy our constants. So if we take if we let's say take a stick of length n by 2, and we take another stick of length n by 2 plus 1, then it would be just n. So this is the length of stick A, this is the length of stick B. So this would be just n plus 1, and this would satisfy our question. So if the question asks what is the minimum possible parameter, then we have to consider these two sticks, and we can, and if we consider any two sticks whose length is greater than this, then this constants would be satisfied. So what's the maximum length of stick that we can take? So we already took stick of length n, so now we can take stick of length n minus 1 and n minus 2. These are the largest possible stick stick of these are the largest these are the longest stick left to us. So a is n minus 1, b is n minus 2, and now if you plug this into this expression, we would get 2n minus 3 is greater than n, and that is n is greater than 3. So if we have, so if our n is less than equals to 3, then that means our answer is not possible. So in this case we would print -1. In every other case we would just print, so in a we have to print the parameter. So in every other case we would print just n plus n minus 1 plus n minus 2. And I think coding this is also simple, so we could skip this. Let's move at a more interesting problem. So we have largest to smaller. Okay, so an integer x is said to be good if there exist indices I and j such that ai is less than x and x is less than aj. Okay, that is there exists a smaller element and a larger element. Okay, so uh you are given an array a, and let's say you have an integer x. So x is good when there are two elements in the array such that one element is smaller than x and one element is larger than x. So let's say there are two elements in a, let's call them A and B. So that means this should satisfy. That is, at least one element in the array A should be less than X, and at least one element in the array should be greater than X. And there is no constant on I comma j. So uh, that means we just have to check if this condition holds. That is, at least one element should be smaller and at least one element should be greater. So we see some kind of ordering here, that is one element smaller, one element greater. So we can sort this array, and if we sort this array, then the first element would be the smallest element and the last element would be the largest element. Let's say in this example we have 1 and 10. So 1 is the largest element, 1 and 10 is the small, sorry, 1 is the smallest and 10 is the largest. Now if we take any element, if now we have to find all possible x. So if x is 2, if x is 3, so if we take any element from 2 to 9, if you consider any x, then it would satisfy the constraint, right? Because if you take 2, then the smallest would be 1 and the largest would definitely be 10. If you take 3, then this is also satisfied. What happens if we take element greater than 10? So if we take 11, then the smallest is there in the array but largest is not there. And if we take any element that is smallest than this, so if we take let's say 0, we are considering only positive integers, but for the sake of example, let's say if we take 0, then there is a the larger element is there in the array but there is no smaller element in the array. So that means our possible access lie in the range of 1 to 10. So that is, x will belong to the smallest element, in this case 1, and largest element 10. And this is an open interval. Okay, so we have to output the number of good integers. So if we look at this example, can you see the output of good integers? So we have how many elements? 2 to 9. That is, we have 9 elements. Sorry, we have 8 elements here, because 1 to 10 has 10 elements and we can't take 1 and 10, so that means we have only 8 elements. So how can we find this number? So this is just 10 minus 1, that is 9, and we have to do a minus 1 to get this results. So we so coding is also simple. We will just sort this array, and let's say smallest element is let's call this array A. So smallest element is A0, largest element is A of n minus 1, and so our answer would be just largest minus smallest minus 1. So I guess this is also fairly simple. Now let's look at S2T. So we are given two binary string S and T, and our goal is to make S equals to T. So we want to make S equals to T using at most 3 n operations. And to do this, we can only perform operation on S. And what's the operation that we can perform? Like if Si equals to 1, then we can flip Si plus 1. Okay. So if it's not possible to do this in 3 n operation, then we print minus 1. And if it is not possible to do it at all, then also we have to print minus 1. To solve this question, we need to make few observations. Uh, let's look at this. So first let's consider S, and we have, let's say, 1 here, and now we have bunch of zeros. Now to flip element, we need a 1 in the previous position. So let's say if I want to flip this, I need a 1 in the previous position. Okay, but we don't have a 1 here, but we have a 1 here. So that means I can flip this first. So if I flip this, then this would become 110000, and now I can flip this because now I have a 1 in this position. So that means I can flip this to make this. Okay, now I can also flip this. Why? Because I have a 1 here. So I can make this, and so on. That means I can make this all ones. So after getting a one, so if I have a one somewhere in the string, then every substring starting from it can have one. So that means if I have a one at ith position, then from I to n position I can make all ones. Okay. Now why would we want to do that? Because if we have a one, then we can flip the element, and if we can flip the element, then we can obviously make it equals to t. Okay. Now what's the other observation that you can make? Let's say s starts with 0 and t starts with, let's say, 1. Now can you ever make this element equal? No. Why? Because you need to make this element, to make the first position equal, you need the element before it, but there is no before element. So that means if the 0th position is not same, then the answer is always -1. So our first check would be this: if s0 equals not equals to t0, then print -1. Okay. now now we can try to make s equals to t in into an operation only. How? Okay. So as we seen earlier, if we have a one, that then we can make more ones in the s. So our first goal would be to make as many ones as possible in the string s. Okay. So how would we do that? So we would just iterate from I equals to 0 to n, where n is the length of the string. And what we do, we check if si equals to 1, then what we do, if s of I plus 1, if this is not equals to 1, that means if this is 0, then we would flip this, and if we flip this, then si plus 1 would become 1. That's simple. So we can do this for less than n minus 1. So in an operation we can make, uh, let's say, make as many ones as possible in the string s. Yeah. If it is possible, then we have to print the number of operations performed, and we have to print the order of the operation. So that means whenever we are doing this, we have to make a counter. We have to make a keep a counter, and let's say we can have a vector which stores this integers. So let's say we have a vector of int k. Cool. Okay. So we could do this. So we can have something like this here, and we would have count plus plus, and we would make s of I plus 1 equals to 1. And what we would do, we would also push this into k. So in k we would push k dot push back, and we would push this index. So we would push I. So that's what we will do. So now we would have at most as many ones as possible in the string. Cool. Now, so let's look at example key to better understand what we are doing. So initially we have s equals to 0 1 1 0 and t equals to 0 1 0 1. So in the first operation, what we did, we make s equals to 0 1 1 1, and now we have to make it equals to t. So now we would move backwards. We would iterate from backwards. Why? Because we can only change the I plus 1th element. We can only flip the next element and not the previous one. So we would iterate from backwards, and we'll check whether this element equals to this element. If it's equal, then we would move backwards, and we don't have to do anything. Now we are here, and now this is not equals to this. then what can we do? We check if our previous element is 1. That is, if this is 1, since this is 1, that means we can flip this element. So now we would flip this element, and if you flip this element, so then we would increase the counter, and we would push this index into the vector. So we would do k dot pushback, and our pointer, let's say we are iterating from for I equals to n minus 1 to I greater than equals to 0, I minus 1. So we push I minus 1 because we are here and we are checking if the previous element, this is I minus 1, index is 1 or not. And if let's say if this is not 1, then that means it is not possible to make s equals to t, and in that case we just print minus 1, and we'll do that until we reach the end of the string s. And if we reach that, that means we have make s equals to t, we would print the count, we would print the k array, and if it's not possible we just print minus 1 and we would exit. So I will code this solution because it's a little complicated for okay. So let's code it up. So it's this one. Just a minute. Yeah. So let's code this up. Okay. So we would have the length of the string, and we would have this s and t. So let's say we create a string s and t. We would take this input, and now we will check if s0 not equals to t0. In that case, we just see out minus 1, and we just return from here. Okay. So I'm not taking this as input nt because I'm not taking this uh, I'm not taking nt as input in the solve function, because what I'm trying to do is I'm taking the number of test cases in the main function. So this is my main function. So I'm taking the number of test cases in the main function, and for each test case I'm calling this solve function. So for each test case, this solve function would be called. So we are taking the length of the string, then we're taking input the string is, and if this is not equal, then we just print minus 1 and we are done with the algorithm. But if this is possible, so let's maintain count, and let's also maintain k. Okay, so now what we'll do, we will just iterate from I equals to 0 to I less than n minus 1, because n is the length of the string, I plus plus. And what we do, we check if si is equals to 1, and s of I plus 1, it is equals to 0. That means it's not equals to 0. Then we'd make si plus 1 equals to 1. So we'll increase our count, we'd make s of I plus 1 equals to 1. So this is a string, so this would be a character, it would not be a integer. So let's do that. Okay, and now we'd make this a 1. Okay, and in our k vector we'd also push this, so we do k dot pushback, and we do I. So now this take at most an operation, and we can do to an operation, and in an another an operation our loop would be over, so we are not exceeding this limit. So we are within 3 an operation. To be precise, we're doing this in 2 an operation. Okay, now we would travel backwards, so we do I equals to n minus 1, I greater than equals to 0, I minus minus, and we check if s of I equals to t of I. If this is the case, then we are done, we can continue to the next index. And if this is not the case, then we will check if s of I minus 1, if it is 0, then that means now si is not equal to ti, but and our previous index is also not equals to 1. So that means we can't flip this element. So in this case, we would again just print -1, and we would return from this, because it's not possible to do this. Otherwise, it's possible to flip this element. So we would just flip this and we would increase the count, and we could just do k dot push back I. Now we can also flip this, but even if we don't do that, that would work, because we aren't performing any more operation on this kind index. But for the sake of correctness, let's do this. So we just make s equals to ti. Yeah, and I think that's all. Now we just print k, and sorry, first we have to print the count, and then we have to print the array k. So I'm using a shortcut, so this should print the vector k, but in your case you might have to loop through the array and print each element. Now let's try to run this. Yes, 2 2 2 minus 1 1 0 0. Yep, uh, seems correct. This can be different because there are multiple solutions that can be possible. So let's try to some. Okay, so there's some mistake. Let's see what's the mistake that we have made. Okay, so this is equal, so this will make sense. And now we are going from here to here. Cool. And we are checking if si equals to 1 and si plus 1 equals to 0. So this would be true for this index only, right? Right. Okay, so at this index we would make this one. Cool. And we might have pushed this here. So do you want it? Okay, so let me check what we have to put in the k. So if it's possible, please print an operation sequence. So operation is we're choosing I such that si is 1, and okay, right, right. Is it a 0 based index or 1 based index? Acha, our I is 1 to n, and so that's one mistake that we have made. Uh, the question is considering the index index to be a array to be a 1 based index, and here we have considered the array to be a 0 based index. So we have to make this I plus 1, and here we also have to make this I plus 1. Oh no, here it was already correct, because we have to push I minus 1 earlier, but so that was one more mistake there. This should, yeah, this should give the correct answer now. Okay, now what's the other mistake that we are making? Hmm, so this part looks correct to me. There can be some mistakes. So if this is equal, then we are moving on. Okay, cool. Here we have to check till greater than 0, because in that case this would not be possible, and even if this is, so that would work. And here we're checking if, oh, right, so it's a character, it's not a string. So that was another issue. Now cool, now hopefully this should pass, and I would keep this mistake in the video, so uh, so maybe some of you might learn how to debug this. Yeah, and it is passing. So that's all for this video. Thank you.